Hello, everyone. Welcome to Class 6 of the Data Manipulation and Management class in Omaha Data Science Academy. This class will be all about structuring and modeling data. So up to this point, we learned a lot of fundamentals about SQL and relational databases. So how to query data, how to ask for that data from tables within a relational database. Then how to create your own data structures to store and manipulate data. The last two lectures have been about then how do you bring disparate data together in the database and combine it into one data set through joins and unions and subqueries. And then the last class was all about applying all the knowledge of those first four classes to be able to clean and summarize and manipulate data, basically the way you need it to be for analysis or business intelligence or for whatever purpose. So this lecture is going to take a little bit of a turn from that. So this will be structuring and modeling data. So still applying all the fundamentals we know. This is more about how do you design a database to effectively meet the needs of your system or an organization's data needs through either online transaction processing, so the ability to be able to capture and store transactions as they're occurring in a system, or arranging data and modeling data for the purpose of analytics projects, so people can easily ask business questions, can look back historically at data, and just really be able to easily and reliably use it for analysis purposes. So this is really starting to get into how you architect a database for these two purposes. And then today we'll go through some diagrams that will help you do that, and kind of examples and use cases for that. So what would be the purpose, or what would be a good example or use case of designing a online transaction processing system or an online analytical processing database and system in a relational database such as MySQL. All right. So class 3 through 5 covered this pretty well in the intro. We have covered quite a bit of ground as far as the class is concerned. So the creation, extraction of data, the transformation of data, manipulating data by adding, removing, or modifying it, and then storage and retrieval. So really, now you have the power to do quite a bit with relational databases and using the SQL programming language to kind of command the database to be able to do these different things. So now you have the power to create new data sets and combine disparate data sets, perform queries, aggregations, and joins, add, remove, and modify data, and extract and store data. So pretty powerful tools at your hands. We've learned pretty much everything except advanced database administration, which would be, like it's probably its own course as far as the details and management of a database system, but definitely the skills that you would use as a general user of a database or a data analyst or a BI developer is concerned. In the final class, we'll learn a few more advanced functions of SQL databases. Just some things like stored procedures and database triggers, and creating your own function. Some extras that might help you better apply what you've learned in class, and to bring awareness that these functions exist in databases and why they do. But definitely, even now, you have a pretty good skill set as far as being able to navigate a relational database and being able to do pretty much whatever you want with data, as long as if it's stored or not. If it's not stored, you have the tools to be able to store it and query it and update and delete it just the way you need it. Right. Class 6 objectives. So we'll cover the purpose of database modeling. I think you can think of it like a house. So it's better to have a blueprint for a house before you just start to go build it. As tempting as it is, and I've even been guilty of it in the past, if you start adding tables after tables, or you don't have a little planning or forethought in front of it, it can quickly become, like a spider web of tables. Or just the design is not as good as it could be. It could end up leading to redundant data, which also leads to, trust in the data or if it's accurate, or just being able to better design and plan for how you're going to design a database and save you some pain and heartburn on the background with a bunch of things that we'll talk about. Entity relationship diagrams. These are how you kind of use natural kind of language to be able to create entity relationship diagrams. So they're database diagrams that define entities, which are like your nouns in a business. So like customers and vendors and marketing campaigns and things like that. So it's really like a way to start at a high level to diagram out a database using natural language. We'll see an example of this, but it'd be something like a customer has a relationship with a vendor. So you could define these in like very high level terms, and you could define that relationship like there are two tables, and then you could define all the attributes that you want to store about a customer. So you can think of any number of things. You could store account numbers, birth dates, anything else related to account, where the person lives, anything that you could think of ahead of time. We'll see an example of this as a tool to be able to help you better plan and model data and design a relational database to your needs. We covered SQL constraints last in the 2 lectures ago. I actually took that one out of here, but we'll review relational database modeling. I think this lecture will really help you understand the different types of relationships that exist. So we focused on in the 4th lecture just the different types of joins, like how can you physically bring these tables together. So now this lecture, you start to think more about like, is it a direct relationship between the two? Does one record in one table always match one record in the other? Is it a one-to-many relationship? So you can think of this as like customer and transaction. So a single customer doesn't map to, multiple transactions. So likely it does. So if you think of an online store, if you think of Amazon, likely you've bought multiple things on Amazon. Then that relationship between customer and whatever you purchased, maybe a one-to-many relationship. So so going through all this will really get you to think about the different types of relationships that exist and what they possibly look like in a transactional database or even an analytical database. And we'll be able to apply some of our knowledge to and see this, but it's always good to think about relationships when you're joining 2 different tables, what those should look like. Great. So normal forms, we will talk about how to properly design and structure tables. I mentioned a little bit about having a primary key to make sure that all of your tables have distinct rows. That's more or less first normal form. Like we'll cover a couple of other things that lead itself to it being like a well-formed table. So no, I won't get too deep into these, but you may run into databases that are normalized or hear this from people who are architecting or administering a database, maybe a DBA occasionally too. It's good to have awareness of like what a well-formed table and what well-formed relationships look like in the database. Technically, you can import a bunch of data into a table that's not first normal form, second or third normal form. But I think what you'll find is as you try to create relationships with those, you have some challenges. So this helps you with some of those challenges also. Then analytical processing, dimensional data modeling. So show you a way to model data specifically for analytical purposes and to answer organizational questions. So a very like straightforward way of modeling data to be able to say, what are my top 10% of customers, or which locations are our top retail stores? Like a really good way to structure data to answer management questions, which can be very different than how you organize tables and store data for transactional systems. So I want to cover that. In your career, you'll very likely see both. So it'd be good to have awareness of what those look like and how you could possibly interpret them and then utilize them. And then we'll cover an example of database modeling. We'll use the Scikit database now. We took a look at that earlier in class, we'll reverse engineer it and look at the schema. Have a COVID-19 data set that we could take a look at, but I've also updated the class project for this purpose too. So we could look at the COVID-19 data set, but especially the class project with the video games and the consoles and so forth. Created a schema that might help you out with some of these concepts also. So we are going to keep on rolling. And then we should be able to cover quite a bit of this in the first hour. So when we talk about database modeling, the OLTP, online transaction processing, it's focused on the operation of a particular system, which a goal is to design a database management system that captures events. So like I said, these are kind of like the steps over here in this graph. Some of them that you might undertake is gathering requirements, updating your data models, creating an ERD, updating that into a physical model, which is like the tables that you would build in a database. You start to look at technical and performance considerations. Then the details of it, like how you define your columns, your tables, your keys, the relationships. And then you update the data and you're off and running. Now, in all practicality, it doesn't always work this way, but some of the more well-defined systems, people take a lot of time to gather requirements up front for those. Like, what should the system do? How should people be using the system? Then how do we create a system that really captures that in the right way? So I've definitely come across systems that that gets to some point where nobody's really entirely sure how it works because of maybe it was well designed at first, but they've added on to it, or maybe it wasn't designed at first and they didn't ask all the questions up front, or you didn't think of them. But this is really like an attempt to be able to do that in the best way possible. And it takes a little bit of forethought, and then just planning that goes along with it. So the model here, it maps how information is stored and relates to other data as part of creating these different models in the middle. ER diagrams, we'll see that in a second, is a good way to start this conceptual data model. Like, how would I even start to go about building a database and tables in one of these things. Like, it could easily get pretty overwhelming, right? So all these different people need different things. Being able to draw it out, and then how do you design a database for that? So being able to draw out all these things kind of gets it on paper, and you start to really define those relationships, and I think it becomes a little bit easier to do so with these diagrams are a tool for doing that. And it becomes then a map of the database schema. So once you have all these requirements, you can start to take it to the technical people to help them design and implement it. So that's the purpose of database modeling. It kind of just puts everybody on the same page as far as this is usually the business part, and this one would be these two, the logical models. This would be like a business analyst going to get requirements and working between the teams. And then you'd have your IT teams that figure out what is the best way to implement this system or this new database that's going to sit underneath the system and help it operate. Right, so the tool to help you do this, one of the best, is entity relationship diagrams. So ERD diagrams describe interrelated entities of interest in a specific domain of knowledge, along with the relationships that exist between them. So a specific domain of knowledge, that might be, within marketing, you have a CRM system that needs to do certain things, or the ERP system is really like designed for enterprise wide, and it has different functions within it. But the domain of knowledge can be as specific as almost like a specific function, like a point of sale system. I would say one that gets transactions within like fast food or any retail place, really, and the design for that all the way to an enterprise wide system. So like an ERP system, or some businesses will end up choosing to even create their own systems, and this helps them define what that looks like. Right, so there are 3 parts to entity relationship diagrams. So their entities and nouns are the nouns that describe the business events of an organization. So these nouns are really like the tables that you would create. So you'd have like the customers. And when you say business events, it's like customers, and then what events do the customers actually do? Or how do you want to describe a customer or define a customer? And then the relationships between them be kind of like the transactions or the business events that occur. So you can have any number of entity relationships, but always think about in a database, the tables are often like the nouns, like the physical things, like transactions of any type, accounts, vendors, products. I was trying to think of any tables that would be verbs. I can't think of any off the top of my head, because those are usually how you define the relationships. But if you think of tables in general, just like in our project, it would be consoles, or in the COVID data set, it'd be countries and states, or in the world database also. You're generally on the right track when looking at tables in a database, assuming that the tables are descriptively named and there's some design behind it. Attributes support decision-making, reporting, query, and analysis. These are the adjectives. So these are the things within, really within the tables that describe like a customer, where they describe transactions, where they describe products. Within a system, they'll help store that information, and then you can use those for decision-making process purposes. These are always like the fields that are within a table. So you have your nouns. Let's say you had a car, and then your attributes would be like all of the adjectives that describe a car, right? So it'd be color, be make and model, be year, and things like that. So in general, while you're designing the database, it has that kind of structure. And the relationships represent the key business entities upon which the transactions are executed and which analysis is conducted. It describes the key business entities. I feel like I have these backwards. I'll update this slide, but the relationships are really these lines and the actions that happen in between each one of the entities. So I actually have an example here. I'll jump to it just to show you. So this is one that I worked on with a friend. I helped him design a database for his mobile application, and he uses it inside the store or inside of his body shops to be able to capture any types of events here, especially invoices, and take pictures of vehicles, and then be able to have that record to easily look up on his phone. But one of them would be like a vendor provides service, two-way repair subject. You can literally like follow these relationships. So a vendor would be, any repair shop. A service would be like the service that they provided to some type of repair subject. So it could be, we did repair subject instead of cars because we were thinking a little bit bigger. Like you could fix small engines, you could fix boats, you can fix RVs and such. And this is the relationship. So this is the verb. So a service, once a vendor provides a service, it services a repair subject. Like all the way down to somebody's lawnmower, their home, or so it could be a house even, or something inside of their house, like a dishwasher, or I know oftentimes our laundry machine and dryers, they break like every 6 or 7 years the way our family uses them. So even something like that. So then it's inside of it, you say, well, what do I want to know about the repair subject itself? And then if you have an invoice, you can attach images and descriptions of the repairs and stuff like that and generate the invoice. So pretty cool design. We never actually got it off the ground, but the idea was there and the design was there and everything. So hopefully that helps bring the entities, attributes, and relationships to life. Here's an example that we used from the project that we did. So like we saw in this one, it often starts with gathering requirements and then designing a model around it. So this is when we were gathering the requirements. So like, what do we want the system to do? And then some business rules for it. So like how should this system operate? So you'll start to see it starts to become very like natural language to be able to define like the entities, the relationships, and the attributes in each one of the tables. So I highlighted the entities in bold. So it's things like we just asked him, as far as the guy who had the vision for this system. He's a non-technical guy. He's worked in body shops all of his life, but he's a domain. He knows his domain and knowledge and everything. So it's a matter of kind of bringing that information out from him. So just starting to ask him questions about things in his business, like multiple vendors can have relationships with multiple owners or no owners at all. So it starts to say, okay, vendors is something we want to define, and a relationship between them and owners. And then what type of relationship? So they could have a relationship with multiple within the app or none at all. Maybe they're just a vendor who just signed up for the app and they don't have any connections to owners yet. And the more more as you go through this, I won't read them all here for you, but it'll start to give you a feel for the types of questions that lead you to a database design, such as this one. So defining vendors and business campaigns that you can run. This would actually be a vendor account. So a vendor registers for an account. And here's where it starts to become important to understand. We call it the cardinality of these relationships, or what type of relationships they are. So you could have like a direct one-to-one. It can be optional. It may or may not happen. Or you can have a mini relationship. So what this diagram shows you, you'll see a little bit. Maybe I can expand this a little bit. Like this relationship between vendor and accounts, you'll see that a single vendor, as a little mark here, can register for many accounts. And they must have at least one account. That one's not optional. But a vendor, there can be a single vendor that provides many services, but because of this circle in here, it can be optional. So maybe they haven't provided any services within the database yet. So it's good to think about this too, because this is often how relationships are defined within a database. And as you'll see, as you join tables together, sometimes you'll see one way I often recognize what the relationship is through a left join. So if you have a single table A and you're joining a table B to it, if you count the number of records in table A, if you have more records of that than that after you joined table B to it, that means that it was like a one-to-many relationship. So that table B that you were joining probably has a many relationship to the single records in that table. So like we say, like an example, accounts to transactions. Say you have 10,000 accounts, and then you have about 10 transactions per account. Then when you join them, both of them, your results, you'll have 100,000 or something in that area because of the one-to-many relationship. And it's not necessarily wrong at that point. It's just something to be aware of when you're defining these relationships and joining tables together. And then it becomes a matter, if you're doing it for analytical purposes, like what's the best way of summarizing this data or bringing it together for the analysis that we need. Maybe it's grouping by that one table and then summarizing the many table in some different way. But it's also important to define the relationships in transactional database like that, because that's how transactions effectively occur. So you would tie multiple invoices you could have multiple invoices on a single line of service, but even tying multiple services to a single vendor is really key. And then the design, the underlying design, this is a high level design. And then the underlying design follows. So once you gather this is really like working with the business, like defining their needs, defining their relationships and what they need the system to do. And that's where you start to see this becomes familiar, right? Like your create table statements. So this would be a relational database model that you create. So the model converts the conceptual representation of entities to a model that can be implemented directly in the database, the physical model. So then you start to see connections between your one-to-one relationships, often between this one isn't, but your primary keys, your campaigns, or your vendors, or even accounts to a vendor. But you also start to define the one-to-many relationships here. So I think we had, well, we do have, so we have a service ID, and you could actually have multiple services in an invoice in this one. So we would define this one as a foreign key. Oftentimes the one-to-many relationships, I originally talked about primary keys as a way to define to distinctly define the records in your tables. The foreign key is often like, how does this invoice table attach to a different table? And oftentimes it's a one-to-many relationship. So like this service, a single service or invoice could have multiple services that tie to a service ID of another table. So it really becomes important, like how you define these relationships, also like how you define the keys within the table and how you connect all of these together. So that's a really like strong design consideration, and why going through all of this, going through the pain, well, not even the pain of, gathering it up front and doing it correctly, because it saves you a lot in the future, right? Maybe you didn't foresee one of these relationships, or it ends up being incorrect, and then you have to redesign it, and it becomes really difficult to do once the system's already going, which happens within systems, like I was saying. But the more you can do up front, the more you can anticipate, the better, I think, without overdoing it too much. Right. So that's all about OLTP modeling. So we have next, we'll cover this part and we'll take a break before we get to the analytical processing piece, which I believe will finish up this lecture. But we'll go into normal forms here and then take a break here, and it'll take about 10 or 15 minutes. But one of the design considerations, and when you're designing keys and relationships between tables, and then how to design the tables themselves, are the normal forms. So these are standard rules for structuring a database to reduce redundancy and increase data integrity. So the better job you do of designing the tables themselves, the less trouble you'll have about possibly creating similar tables and copies of the data, and then how to synchronize them together within a system. It can really become like a tangled web. And then, like I said, I've actually seen systems where it's like going down the highway at 90 miles per hour, but there's no one driving it. I think Michael could appreciate that. No one's at the wheel, and no one's exactly sure how it works.
Never seen it, never been around it.
Not in a system Michael ever worked in or designed or anything like that.
Yeah, how do you not bump into that?
It's hard though too, because eventually, like, people want to add things on after the system already is already up and running, and then, but if you have a good like architect or somebody who really knows the system, they can provide guidance on. If they design the system, you can provide better guidance. A problem in organizations I've seen with that is that they don't have any of those people anymore. So nobody really knows how the original system worked.
But that's what my
design it.
Question.
Watch out for the words. Watch out for the words. It's just simple, or this one small change.
Yeah. Yep. What were you gonna say, Ronnie?
Well, when you were talking about defining the nouns and the adjectives and
Sorry, Ronnie, you froze a little.
Mm-hmm. Oh, it looks like she froze in time there a little bit.
And I'm hanging on the words. I still want to hear the rest of the question.
Yeah. I'll wait till she unfreezes. Hey, Ronnie, you're back. We missed
okay.
you.
Yeah. Okay. At one point, do you engage or involve the end user in the design? Because I think that's where the failing or those questions come up, is you didn't even include us end users that have to deal with it every day in the thing. So yeah, of course we're going to ask for one more thing or one, because that's where, when we were defining the nouns and the adjectives and whatnot, making sure the right people are at the table at the beginning of the design without having all the cooks in the kitchen too. Because I get that in designing anything, technologically or architecturally or whatever, you have to have limitations on who gets a say in what the end product will be. How do you make sure what you build is impactful for the ultimate, and or there are ways to bring them in at different stages, I guess, because that's where I'm fighting in an educational organization, that the reporting is all up the chain to the feds and the state to the accountability folks, but to impact and change what those results of the data that they're querying to report up the ladder, we have to be able to know what the skills and things that the kids need this, and that comes off assessments and grading and stuff you would put into a database to analyze in the first place. But to have the teacher and the data administrator and the build the right schedules, all of that, I think, so that balance, I guess, is what I'm.
Yeah.
You
Sorry
can
if I'm
go for it, Michael.
Yeah, sorry if I'm jumping in, Jeremy. Yeah, so I look at this as kind of a part of it. It's a product type of thinking and problem, and part of it's project management. Now, when I said the just and this little thing, that's usually something that happens between somebody who wants something and doesn't realize the impact what it's going to have, and the person who has to support it or take care of it. So basically, like if I was a developer and I asked the DBA, "Oh, just change this one thing and make whatever." I'm trying to make my life easy. And getting the DBA to deal with a problem that I'm just dropping on their lap. But your questions are, I would say, larger than just those more isolated technical trade-offs. What you're bringing up is more of a product type of thing of, do we add this feature? No one's going to use it. Or do we make this change because without it, the system's not usable? I see those as more like stakeholder and product type conversations instead of deep in the weeds. This query is going to take a second longer or not.
I do think that sometimes when those aren't fleshed out, or even when they are, the technical team kind of has their way and they do things the way that they want to do them, which isn't necessarily like it's good for them, right? It's like technically sound, but it kind of benefits them instead of the end user. And it has to be some type of trade-off, but I lean toward the user. Systems are a little more, transactional systems are a little more complicated because there are really a lot of more legitimate technical concerns on like the ability of being able to do certain things or the design of the system and everything. But from a BI and analytics and data perspective, I see it almost entirely user driven. Like if it's not meeting the user's needs, like how do we get the data in a certain way or format or deliver it in a way that's most useful, which is probably less technical concerns in a system.
And I would say too, if you're not taking care of the user's needs, you're not going to have users.
Yeah. So it can go crazy in an organization, right, Ronnie? Like 50 users are requesting like 200 different upgrades, right, to the system, but there's like no real way you can do that, or it'll make it a mess of the system. So I guess.
But I think to make best decisions, you have to have the right. I mean, again, I use that example of overlapping somebody's grade book or attendance every period. Technically you can make that happen, but okay, once you make that happen, are you going to hire more people that are going to have to go track down the truant students and the people, you still got the one attendance person, but you got twice the amount of data. So who cares if you know the data now, if you didn't hire the people to go out and impact the change now that you know that data?
Well, I think another flavor to your example, Ronnie, is if you don't have this all worked out right, you could have somebody who's going to pencil whip it. And then the data you're going to try to understand from it may not be as clean because it's been pencil whipped versus someone who meticulously or diligently took care of it. But
So Ronnie, you're kind of talking about system capabilities that lead to the data, or are you talking about the function? You're talking about the system functionality itself to let you do certain things?
I think just a comment of just understanding, how when you develop it, that balance of technical knowledge that the capacity, but the end user that you get all those, and sometimes it's unintended consequences or unintended. You don't know until you built it that now this asks 3 other questions that we didn't know we even need to take a look at because we didn't know that the data was going to come together that way. So not a right or wrong, but I think the end user, has to be at the table.
Yeah, I think with data, it should especially be end user business driven, right? Because they're the ones asking the questions and finding out new things and stuff like that. Yeah, and then the systems often they like, as you see in this lecture, like a transactional system's designed for a very different purpose than how you usually very different than how you typically use data too. So you design for that also. And then trying to balance all the needs as a balancing act. It's a little bit like I don't know if Michael will agree, like the circus bear with like all the plates on top. And I guess eventually it's all the trade-off. Like you eventually need to bring the stakeholders to the table to best meet everybody's needs. But it's kind of they call it in MBA school, they call it stakeholder theory. Instead of just saying that you're going to do something, it's kind of like bringing everybody to the table and trying to find the best resolution possible.
And it's better if they don't do it. Sorry, Chairman, go ahead.
No, go ahead.
I'll say it's better if they don't do it through you. let them, if they're opposed, work it out, and then you just record it.
Yeah, and sometimes there's a real disconnect between the business side and technical teams. It gets lost in translation, which is why these tools are important too. And getting a proper design and getting signed off. And I do like Michael's model of, the product owner model too. Someone who really has a stake in like its success and will be there at the table. Because sometimes that can work in reverse too, is that the technical, being on the technical side, the technical people will try to meet with the business people, but the business people are like, well, why don't you just do this? Or we aren't interested in any more meetings or whatever. So
you know how to do it, just do it.
Yeah. It's like a simple change. I don't know what the big deal is here or what this is going to impact, but that's why we have you here.
I just want to see it in green now.
It's all communication and a two-way street, and gathering requirements is like that piece of it, right? And having people actively involved in the system and having stake in it and owners of it to make sure it's done properly, I guess. So Ronnie, I would recommend probably to you, if you see those things, maybe becoming a stakeholder of the business or a product owner, and working between the two is, even James said it the other day, Michael, is being able to work between the non-technical and technical sides, just one of the greatest values you can provide. There aren't a whole lot of people who can do that. And hopefully a class like this helps you bridge the gap a little bit too.
Right. Do some translation.
But it brings a tremendous amount of value in these things. Maybe you could become that person, that owner of the system that helps go between, can translate. It's almost speaking 2 different languages in some ways.
Yep.
But so with these, some of the tools that will help you do it here, and some of the background knowledge that helps you connect. All right. So I'm going to get through just normal forms here. I like the discussion. Thanks for stopping me and doing that. We have plenty of time to do that tonight. Not that we don't any other time, but it's really good to take this and think about, like I said at the beginning, it's all about how do you take this and actually use this knowledge. And that discussion was good. And as far as like, how do I take this and how do you define systems and requirements and how would I actually use this, in my job or organization. So I think that's really good. Normal form, so is in the middle of it. So there are standard rules for structuring database to reduce redundancy and increase data integrity. So this is really the design of the tables as far as how they're formed, how their primary keys are formed, and their primary keys and why am I drawing a blank? Foreign keys, yes. So how you design the keys of the table to both define that single table and the relationships between the table. So it's in essence, it's minimize space, costs, and errors, and avoiding redundancy in systems. So yeah, I started talking about inefficient systems I've seen, and that's where it sparked the conversation. But anyway, so there are a couple of different forms. If you were to take a computer science class, you could do almost a whole semester on the different normal forms, but it's not really like that important other than knowing probably first and second normal form. And we'll do illustrations of this, but definitely first normal form as far as uniquely defining and identifying each row within a table is key. As far as removing the redundancy, the complexity of it, and we'll see why it's important here in a second. But second is kind of a breakdown of first normal form. It's kind of like, how do I decompose structurally tables in a way that's both smaller, more efficient, and easier to update and maintain, and is more accurate. So we'll cover these before we take a break. So first normal form, your goal when you design any table, it should be to have it at least in first normal forms. Now, if you're just importing a data set out of a spreadsheet, maybe it's not that important right away to have first normal form table, because you just want to import it and do some things with it and use SQL and maybe join it to something else. But if you are designing a table within a system or for analytical purposes, having first normal form is important, because here's where you're defining a primary key and distinctly saying this record's unique, this record's unique. And it sets yourself up for being able to more easily join these tables in the future. Join or merge or do whatever you need with these tables in the future. So anything past just importing data for a use and seeing how it merges with other data. If you're designing a database, your goal should always be to have tables in at least first normal form, and which also makes them easier to manage and maintain. All right. So the requirement is the table must have a primary key. Talked about that each row is distinct. And it has a few different rules here also. These are really rules when we talk about relational databases. So each attribute, the column value must be a single value only. So what they're saying here is, like, it can't be like a single column can't have two different values. It has to be a distinct value, like headquarters, date. Close price is technically, even with a space, one value, because you can think of like parentheses around that in a single column name. You can't refer to a column two different names, the same column with two different names. So a lot of these, you actually can't even do it within these relational database management systems. Like if you were to try to give a column two names, the database management system like MySQL wouldn't let you do it. So the second rule is all values of a given attribute must be of the same type. We talked about that earlier. So when you're building a table, you have to give a column, like even if it's a varchar 2000, you want to give it 2000, characters that you can enter into a field. Even if they're all different lengths within there, the data type of all of these in the column are varchar 2000s. Or, all of these, if you're defining date as a date field, all of them must be dates. Close price, if it's a decimal, all of them must be decimals, and so forth. So kind of interesting, like newer databases, non-relational databases are now allowing you to have mixed types in columns. But really why SQL is as popular as it is, it's very rugged, not rugged in its structure. It's very much a structured like database management system. Like for structured data, you either it's already structured in a system or you structure it. It's really a way to either in a transactional system, be able to structure and capture transactions in a structured way, or for analytic purposes, you're storing historicals in a very structured way.
Hey, Jared,
And
can I
lots
ask
of
a question?
yeah,
I'm sorry to interrupt you. So, using your example of the close price, the reason why I should strictly adhere to these rules is because of things like, even though you could say, like when we visually look at it, 2414 as a close price as a number versus in like a single or double quote, we can interpret it or understand it to be, a number, but you can't, like when you add a string that's 2414 to another string that's like 28, it has a different outcome than if they were numbers, right? Is that what you're getting at?
yes, yeah. Well, you're talking about two columns, Michael, or my previous example?
Oh, sorry. Yeah, where you have to have the same consistent information in a column. You
At
can't
least
mix
down a
strings and
single
bits.
column. Yes. So that one's a little bit different, I think, Michael, in the sense you're talking about adding two columns together where one's a number and one's like some type of character string.
Well, I guess what I was trying to note is the close price looks like it's decimal, and you'd want all rows to have a decimal in that column, because if one row had a string and one had a decimal and you go to add them, you want to have the expected outcome.
Yeah, you couldn't apply like a sum function to it. Plus, the relational databases are really strict. Like, it forces you to conform to those, which is the constraints that we put on the table when we were building it. Whether it's value constraints or row constraints, it really allows you to build like that strong structure of the database, like not just the database or the data that's in there now, but like how database is inserted and updated and deleted from the table also. And that's just one of them, is that you can't really have mixed types because it doesn't make a whole lot of sense when you're summarizing a data. But I was saying just a minute ago, now with analytics, there are a lot more unstructured data sets that have like mixed data types. So now there are new technologies, and in my very last lecture, optional lecture, it outlines some of those technologies. But for analytics purposes, like some of it's even moving away from this type of structure, but still relational databases and SQL are the most widely used because they're more familiar to everybody, and it's really like the strongest, most fundamentally sound way of structuring data to this point. But if anybody would like to eventually learn about those alternative technologies, I'd be more than happy to teach them for analytics purposes, like your big data or unstructured data and stuff like that.
Cool.
But anyway, got off my own track here a little bit. But that's the point of first normal form. Let's see, each attribute column name must be unique, so you can't have headquarters and headquarters in two of them. They need to all have different names. If you were to create a table, it wouldn't let you do it if you had two columns with the same name. No two tuples in a relation can be identical. That's where usually the primary key comes into play. Although the primary key is a value that uniquely identifies it, which would help with this. You couldn't have this row right here, the Microsoft on 9.9 at 24.1. You can't have that as a duplicate row with all those same values in the table twice. Otherwise, it violates first normal form. And the order of the tuples is insignificant. So it doesn't matter what order these are in, even if the dates are in different order, you can still get the same result when you write a query on it in SQL. Which is kind of nice because you usually don't want the order in which data goes into the table to really impact things that much. Like now, transactions often sequentially go in to a table, but whether if the date, maybe it's entered in on 11/3 at 8 o'clock at night, whether it's on the bottom row or the top row is not going to matter that much. We're somewhere in the middle of all of them. So the order doesn't matter. It matters that they're sequentially entered with a timestamp, but it doesn't matter if it's the first record, the 10th record, or the last record in the table. And all of these most of these by default, like I say, are like built in to MySQL. Like the order isn't that significant, or where you put the order of the columns aren't until like you're inserting data. Then in that list, you have to put them in the same order you're inserting. But what if close priced is the third column? It doesn't matter. The third column versus the fifth column, it doesn't matter that much. So I would call it structure with flexibility, and first normal form's way about going to do that within a relational database. All right. I'll cover one more slide here. So second normal form is a breakdown of first normal form. You see you have the first normal form and you've broke it into two tables. So I should mention in this previous table, each row is uniquely defined by the symbol, the date, and the closing price. So the key has three parts that we call a composite key. So if you have a composite key, you can actually break these down potentially into two different pieces, into two different tables. All right, so the requirement is that the table is in first normal form. The rules are a relationship is in second normal form if all of its non-key attributes are dependent on all of the key. So I'm going to break that down. That's like computer science language there. So breaking that down is these things that aren't part of the key, like company and headquarters, they're only dependent on part of the key. And then you could break that down and kind of separate it into two tables. So the only thing that really company and headquarters are dependent on is symbol. So you can have them in this table, but they really aren't dependent on the date or the close price. Just knowing that Microsoft is in Redmond, Washington, and the company is Microsoft, that can be its own company table or symbol or company table right there. And then the stock price is only dependent on the symbol and the date. So the close price is just dependent on what day and what the symbol was. It's really not dependent on the company or the headquarters itself. Just that Microsoft is the ticker in the stock market. So this actually leads to even more efficient design because you can see these two tables are smaller than this first normal table. Plus, when you are updating records or deleting records, you don't have to go and update everything that's Microsoft. You can just update one record here and one record here. So it actually becomes easier to update records and add and delete records if you're in second normal form. As I said, you probably, this is like, I just cover these briefly because it's good to understand how you can break down these tables. You don't necessarily have to know too much about it, and you may, in your career, hardly even ever hear about it itself. But it's good to know, like I said, how you can decompose these tables, and then just thinking about data and the relationships between them, and potentially how you can design these tables even a little bit better for your own purposes or bring them together. And likely you'll see tables like this within a system or something, and you can tell if you have tables in this form, it's probably the relationship between the two is a little bit easier to define also. All right, so covered quite a bit there. Is everybody good with taking a break? Anybody have any questions about database design? I know it's a little bit different than what we've been covering, but I've said it a couple times. I think it's really good to know this stuff about, like, now, like, how are these constructed? How do you design this to really, like, maximize the relationships between the two, and then just thinking about the relationships as you bring tables together. It's kind of another way of doing it. Anybody have questions? All right. Nobody brought me down food today, so I'm going to have to go scavenge here, I think.
And then when you get back, I want to just get the installer going right before we get back, but I'll let you go get a bite to eat quick.
Okay. Yeah, we actually only have one more slide, and then we have an exercise here with that Sequela database that like Blockbuster video movie rental schema.
Okay.
So you can see it in place, and then we can work on class project or whatever after that. I do want to walk you through class project because it kind of puts all this together that we're talking about, like what it looks like when you're designing a little mini system here for managing data. I'll show you what that looks like. All right.
Yeah, and I'm not entirely caught up on the class project. I'm about milestone 3. So if we could quickly kind of walk through to make sure I am doing the right thing, and I'm
Oh yeah, no problem.
that would be helpful for me.
So we'll take 15 minutes here, and we probably only take like 15 minutes to do the rest of this. So you should have like an hour to work on it.
Okay, wonderful.
Or so or more, so we can cover all the rest of the project too.
Wonderful.
Cool.
All right.
I'll have plenty of time to work today.
See you guys in 15.
All right. See you in 15.
See ya.
Here, Ronnie, I'm back. Oop, I don't hear you.
In the custom install, I wasn't able to do the connector Python because I don't have Python installed on it yet, I'm assuming.
Yeah.
And I didn't get the document and samples, so I'm in the middle of the configure server. Is it okay that I go ahead with the configure server, or I should go back and install Python first?
No, you can do that later with Python.
Okay. But when I do the and then do the development computer standard settings, I'm at the authentication method right now. Do use the strong password encryption?
Let me double check that real quick. If it's my own computer, I generally don't, but let me.
Yeah, because otherwise the other option is use legacy authentication method, retain MySQL 5x compatibility. So I was doing the most recent version of MySQL, so that 8.0 or whatever, but if I need to go back and choose a different one, I was just choosing the newest,
Hold on.
most recent version of everything.
So you're at authentication here, and what were your two options? One was strong authentication.
Yeah, use strong password encryption for authentication, which is what's recommended. And currently MySQL 8.0 connectors and community drivers, which run whatever client support this new method. The other one is to use the legacy authentication method, which retains the MySQL 5x compatibility.
I think you can just go with strong encryption there.
Okay. Okay.
Because everything you download from now on with Python, it will have the libraries, drivers.
And then the root password and stuff is going to be, the username is root, is what I'm just doing.
Yeah. So you can put it as whatever you want.
Right.
I'd make it something safe, because if you forget that root password, then I have to reinstall the database, because it kind of gives you access to everything to set up your own database.
So you think I should use something that I will know, or do from the directions you gave me?
If the directions help you, I would do that.
Yeah, I'm
Just
going to do that.
The username root and the password root. It's not that big a deal to not have like a strong username or password, because you're just using it on your laptop for yourself.
Right.
Anybody else is accessing it or anything.
But it's just adding me for the root account password, so I don't need to add any other users or anything. Just go ahead and put root as the password and go to next, right?
Yeah.
Yeah.
And we did that for class, so like that somebody won't forget their password or whatever. We all knew what it was going to be.
The Windows service name is just MySQL 8.0 is fine.
The server name, let me see.
Because it says Windows service, configure MySQL server as a Windows service, and then the Windows service name MySQL 8.0.
Yeah, Windows service name. Okay.
Yeah.
That's you'll have it so the database runs on your computer, and it's a service as a service.
Right, and that's just the standard what it recommends. Do I want to check the box though? Start the MySQL server at startup or at system startup, or not?
Well, it depends. It depends on how often you think you'll use it. You could always start it up after you start up the computer also.
But I mean, I'm just using this computer just for this class. I'm not using it for anything else, so I might as well.
Oh yeah, then go
do it at the startup. Okay.
Yeah, the only thing, if you do it on startup, it runs in the background and takes up some memory, but it's not really that bad.
When I go to open MySQL Workbench, will that automatically open the server, or I'd have to do, I guess?
I think you have to hit connect, so that's where I was just going with that. So it would probably look like this. Just call connection name whatever. A host name would be this default, the 127.0.0.1.
Okay.
Maybe I can zoom that. I can't zoom this one. With the
Okay.
username root, and then if you hit test connection, it should ask you for a password.
I'm just going to go ahead and let it start in the system startup. Would you say yay or nay?
Yeah, that's fine.
Okay. Standard system account. All right. Apply configuration, writing. I just want to execute that then, and then I'll ask questions at the next break. How's that?
Okay. Deal.
All right.
Just a few minutes away. We'll wait for Michael to come back.
Oh, okay. I didn't see that he wasn't back. Okay.
Yeah, if
No, I'm here. I blipped on earlier, but you guys were talking, so I just let you be.
Okay.
I'm sitting down because my feet hurt.
Standing desks at the end of the day, they can get like that. I guess I get more used to it all the time, but sometimes I have to sit down in the day or my feet will be sore at the end.
Yeah, I did too much walking in Nashville, even with athletic shoes on. My left heel is killing me.
Yeah, that's what I do. I don't skimp out on shoes anymore. I go with the Brooks all the time, whether I'm walking or exercising or whatever. One thing I feel like it's good not to cut corners on.
Yeah, very true.
All right. Somebody said that is I saw some life advice somewhere, and they said don't go cheap on your shoes and your bed that you sleep in. As far as, I guess, just like your posture and your knees, eventually your knees and your feet. Take good care of them. All right. Anyway, let's do this so we can have some time to work. All right, so just one slide here, but wanted to spend a little bit of time on it and so take a break here because it kind of separates these two pieces. So this is about online analytical processing. It's OLAP versus OLTP. So while you can see it's a lot of it's really designed similarly to your ERD or your physical database design, now you're designing these tables really for analytical purposes as opposed to capturing transactions. So like, for example, with the OLTP database that we designed for the repair shop, for the auto shop, that was really about capturing like different transactions and relationships between those entities. So like a customer or a vendor can sign up for an account, and that captures that unique activity. And then a customer can provide a service, which captures that activity. The service can have an invoice, captures that. So it's really about like designing a database in such a way that most efficiently captures transactions without much redundancy or confusion or anything like that. So this is really a data, like while the database design looks similar, this is really designed instead to answer analytical questions. So the focus is really on the data more so than the system requirements or the transactions. So while knowing the type of questions that could be asked by management's important in this design, it's not as critical probably to get like the system requirements up front. These data models often develop themselves as more and more questions are asked, or you bring in more data and so forth. All right, so two different ways to do this. So there's a star schema. It's very intuitive. So what you have in a dimensional model is that you have a fact table surrounded by dimensional tables. And you're likely to see this type of data model in an analytical data mart at some type of bigger organization, somewhere that's already built a data warehouse or data marts or something like that, something similar. Maybe even OPS might have something similar that they put together. But you'll have these fact tables. They contain, if you think in a Tableau sort of way, these are like the measures. So these are the things that you can summarize, like price or quantity, and they store facts about usually like some level of granularity. So this would be about the product, the time, the store, the employee, and what type of sale it was. So you think it's when you think, I always think when I'm doing analytics or doing a report or something, it's like, what level of granularity do you want? Or what summary level of the data that you want? Oftentimes you just want the raw data at the lowest, like the details of the transaction, and then you can summarize it up. But maybe sometimes it's not possible or it's not as efficient. So maybe you want to store inventory levels on a weekly basis instead, and that would provide you the historical information you need. You could do that in a fact table, maybe like the current price, current quantity, and the products that go along with it. So basically, those measures, anything that you can, any great level of granularity that you want in the measurements that go along with it. So the dimensions then are, you can see, structured with like single joins, almost always one-to-many relationships because this is many facts. And it's sort of a semi-normalized table that contains employees. With this one, it contains employee information, contains information about the product, the time, the store, and the type of sale. So what really happens when you design it like this is that you can do a direct join. You can directly join employee ID to employee ID of fact sales. Say you wanted to get all the employees with a birth date in 1992 for whatever reason. You could say, fact sales, and do an inner join with dim employee where the name is equal, or the birth year is equal to 2000 or 1992. And that way you can quickly answer these questions, and it's very like intuitive way for the business to ask questions. So maybe a better one would be with products, maybe get me all sales of cell phone cases that are OtterBox, and maybe you join time here also over the last year or month. And then it becomes like a simple quick join. All of your facts are stored, your business rules and dimensions are stored at each one, and very, very straightforward to use this. You could even load this type of data model into Power BI or Tableau to answer questions very quickly. The type of tools that are designed for this type of model. The Snowflake model is just an expansion on the star schema. You see this left out less often, but sometimes you'll see this that kind of it'll help maintain kind of like the benefits of normal forms. So it ends up being more efficient. So like this one here, you have a store, and then you have the city and the region and the state and the country, more like a data hierarchy and maintaining that piece of it. So maybe you have 10,000 different stores and you don't want to store 10,000 stores in the dim store dimension. So you can break it down by city, region, state, and country, and kind of make these tables smaller. You see this left out less often just because it increases query complexity. Now you have to do multiple joins and kind of traverse this. And it's a little bit harder to maintain all of these tables also, as opposed to the star schema. Sometimes this one's a disadvantage if you have a lot of, like I said, if you have 10,000 store locations or something like that. But you're likely to see this one, and then maybe possibly this one. I've seen this one a couple of times too. Maybe it's some additional reference tables or something that adds information to store or product. Even with this one, it's you add product type to the dim product instead of having them separate. So really there are trade-offs with both. But this is a way to take that transactional data, take the data out of systems, and structure and organize it in a way that answers business questions. And you can store history at different aggregate levels and manage the business rules around them also, which aren't always prevalent in the systems that you're pulling them from. So any questions about the advantages of this type of data modeling over transactional modeling and some of the differences? I would say that one of their biggest reasons to manage it like this is really like the things that people on the business are most concerned about, like customer lists or manager lists that you actually pull from outside some of the systems that you get the fax sales. Like it just doesn't exist in a way all in one system or the way the system was designed potentially in this. So it's a way to capture data in a relational database in the way that is makes sense and is most manageable for the business. So hopefully, and then the good thing about these is that you don't have to know the intricate details of a system like this and the relationships either. To answer the questions, you can just look at a schema like this and quickly get your answers that you need with a pretty straightforward join, left join or inner join or simple query. All right. So that covers the design pieces. So a different way of thinking of systems thinking and transactional processing versus just thinking more about the data, how you'd organize it and store it. A little bit different thought process. All right. So I do have an exercise here. I think this is a good exercise to really understand relationships. It's a Sequila database that we reverse engineered a little while ago. But you can see it's everything that we talked about. You have the entities, you have the attributes, you have the relationships. This one's like a one to optional many relationship between the two. And then I just ask a few questions about this. This one doesn't have any SQL code to it, but I think that if you can answer these questions, you have a pretty good hold on the concepts today here of database design and online or the design of a transactional database. So you can go through and identify entities and attributes. Think about if it's in first normal form or not. All of these, just a hint, all of these tables are in first normal form. You just have to determine why. Or if there's one that's in second normal form, and then identifying these different relationships in the table and thinking about what they mean. Like this one would be, like you have information about store manager, and address. And then a store has multiple pieces of inventory, right? Optionally many. Maybe it's a brand new store that doesn't have any inventory yet. But this type of schema, instead of just looking at the tables, it can help you understand a database, even a little more complex one like this one quite a bit. And then feel free if you want to, I'll open up MySQL if you want to reverse engineer this or try to bring together some of these relationships. That would be through joins, that would be a pretty good exercise here too. So if you went to Sequila, we'll just go ahead and set that as default. But if you go up to database at the top, like we did earlier in the class, and you hit reverse engineer, then click through some of these. Right now, it's just analyzing the database or analyzing the databases on the server. You can tell it I want Sequila database. Hit next. You can execute. Then you can see all the relationships in the database and the data types and everything. And even how you could connect. So within a database, it might be that's not just joining A to B to get there. You need to join A to B to C. This does a pretty good job of highlighting that. These relationships, pretty neat tool.
I particularly like that. It's highlighting not only the relationship, but the field or the column involved in the relationship.
Yeah. How you can connect them together. So this one, you'd have to go, and there's a film category address. There are two, film actor and film. So yeah, just to get the category, you'd have to go film, and you have to go with the actor within film in this system, and then through inventory, film text, whatever that would be. I guess that's a description of it up to category. So you'd have to join 5 tables together to get there. Could give it a try. But I can also skip to other things like I want to cover the project here too. Just wanted to give you a heads up on tonight's exercises and what you can do. And we'll try to use as much of this time as we can for working time. So for the class project, this is a good exercise. I would definitely go through this and make sure you have a full understanding of these questions and how it applies to the OLTP design that we talked about tonight. So nearing the end of the project, milestones. So we want to normalize the data and create a data model. And I actually helped do this today in the class project. So I imported these 4 tables, and I've created some views that help define these relationships. But I didn't just magically do that. Say I followed the steps here. So created an ERD, and this is now called diagrams.net. If you've ever heard of it, it's like a really awesome free website that allows you to just draw up any type of diagram that you want. And I'll show you an example here. So one of the first things you do just right off the bat is identify the nouns, attributes, and relationships in the console schema. I didn't write those down, but some of the things I Some of the things I recognize out of here are pre-orders. We have consoles, and then we have games. And I think we also have manufacturers out of it. So if I expanded, and a lot of this in designing the model is really kind of exploring the data yourself and understanding the data and what's in it. But one of these other ones has publisher in it, console game rank, and console games. So I'm taking these data, these tables we loaded, and are figuring out what the entities and attributes and relationships might be, and then redefining those. So I'll show you how I did that with a diagram. And Ronnie, this might be like where you import data, and then if you wanted to create a data model out of it, you could say could do something like an ERD and then a physical model. I caught Ronnie's attention there. Surprised her. But I'll show you what this diagram looks like. I don't have to grant an authorization, that's fine. Did that in a different web browser though. So if you have like a Google account, you can sign up for this. And let me know if you probably can't click on this, but there's also a diagram here in Google Drive that you can download and load that into diagrams.net. But you can see it has there's like a lot that you can do in here as far as diagrams are concerned. I think they even have one. They have an ERD, entity relation diagram that you can create. So it's specifically made for entity relationship diagrams, and then you can do physical database diagrams in here too. So right before you're going to implement a database, you can like list out all the fields and the data types and then primary and foreign keys and things like that. But pretty neat tool to do that. So I said I identified the game, publisher, console, pre-order, and I did a game sales there. As far as like, this would be like a game rank, more of like a game rank table, almost like a reference table, where you take the title and then the date of the ranking of because the data set is one where you pull it on like a weekly basis, and then you'd store the historical date and rank, which wasn't quite as good of a fit as in the game one. So I defined these entities and then relationships. And while I haven't implemented the whole physical model, I did create these with views. So you see there's a game, a console. Oh no, I just copied that one. What did I do? And there's some code behind it, but I put these in milestone 6. So if you wanted to do this and create it in your schema, that would also be good too. So I put this one. I'll link you to this one really quick. So it is in, let me pull over Google Drive. Right, so this one is in class project. I created this today, the milestone 6, relational database modeling.SQL. And this is how I created all of these entities and relationships. these entities and attributes. And then you can create the relation. You can join them together to create the relationships from there. All right, and I minimized my window that had everyone in it. So 1 second while I find that. I don't know what I do. Sorry, I lost everyone here. 1 second.
No worries.
Cursive 50 windows open. There we go. Magic. It says lost, but now I'm found. All right. That is pretty much it for tonight. There's also one other thing I should point you to in this Google Drive. It's this diagram that you can open in diagram.net yourself. Diagram.net yourself. Here, go back. If you go over to class project, and there's this video game erd.draw.io. Instead of connecting to it in that link in the PowerPoint, you can download this and you can go to diagrams.net. And then you should be able to open this yourself after you connect, after you sign up for diagrams.net. So you can, once you download it, you go to device, open existing diagram. Give it a second to think about that. And it's probably in my downloads. Yep. It ends in draw.io. And then you can open it that way too. I guess I have a desktop version of it too. You can download diagrams.net desktop. So instead of having to pay for Microsoft Visio or some other tool, I actually find this it's free, which is great, but I think it's pretty good too. Meets my needs. And that's pretty much it for covering lecture tonight. I'll catch more up on the class project or cover some of these examples. There's a slide on third normal form if anybody is interested in that. It basically, I even have a hard time describing it a little bit, but the key is always like second normal form. And then it's a further breakdown of second normal form. So there's no transitive relationships between the keys and other fields. So you can actually take this table and then break it down even farther so that you don't have like symbol, company, and headquarters. There's absolutely like no more dependent relationships. And then it just gets crazier. It gets crazier from there. If you like that stuff, say you should think about becoming a computer scientist. If you wanted to go to that extreme, that's what I did. I didn't find it it got crazy after a while.
And then they go, okay, and then take one step back with the normalizing, right?
Oh yeah, sometimes you go to third normal. Well, okay, so that's a good point. So with OLAP, usually you normalize first, and then it's kind of like a pseudo denormalized form to get it to exactly that data structure that you want to answer questions. There's some practical trade-offs at some point between how much you normalize. And then if anybody can manage it too. If any database guys tell you that they can do anything past, or they can do anything past third normal form, you should call their bluff. Have them buy you a beer or something. Make them prove it. Because I doubt it.
And then you throw down the trump card, but not from my perspective, right?
It's not that bad. I don't know. There are like 10 of these things that are like third normal form or greater. I don't know how practical any of them are, really. Been a while since I even thought about it. I don't really, on a day-to-day, I'm doing BI and analytics. I'm not really designing tables like that.
Yeah, and this might be a lot of inside baseball, but this whole normalization, that was like the only way databases were thought about and taught for years and decades, right? And then like 10 years ago, all of a sudden NoSQL popped up, and all of this explosion of different concepts around databases came out and turned all this on its head.
Yeah,
but I agree with you. This is a must to learn first before any of this other stuff.
Yeah, it's really structured, right? And people are usually used to structured data in tabular format more so. I don't think it's going away as far as like structured data. Well,
Agreed.
systems, of course, but even in analytics, it's probably not going away because it fits like transactional data really well. Until in like business rules and intuition, like some of like the advanced databases and NoSQL and stuff like that, they get really technical and complex to learn, I think. And it's a different mindset with data, and there are all sorts of different types of databases for different purpose. Like Facebook even created like their own like social media like web, it's like a graph database to be able to specifically like figure out people's like third and fourth and fifth relationships to other people. That's why they're always so good at like offering like who else you should be friends with or whatever, or how you're connected to different people.
Yeah, and I agree with you. And relational databases are not going away, even with the inclusion of those things.
Yeah. Now there are whole new waves and categories of data and analytics, so it's not super practical to put everything in a relational database. But even for Gordon's classes, is this the end of the road for everyone, or are you taking Gordon's analytics classes too?
Going on to Gordon's.
This is my last class. It's the end of the road for me.
I like how we separated it, how we decided to separate these things into like the data analyst BI perspective, because there's a lot of use of data in an organization. It's not like advanced analytics, it's this stuff, right? Being able to query and get your own data and answer questions and use Tableau or maybe Python to create a pipeline. Maybe some light Python programming and scripting. I think you have a pretty good start at being a data analyst and doing business intelligence if you go through these 3 classes.
So Ronnie,
that's what the goal was.
Yeah. How do you feel about it? Pretty good?
Yeah, Tableau, out of the 3, I think Tableau was the one that really I clicked the most with. I think that one, it was a little more easier for me to pick up on, and I like the visualization piece. Python is a whole can of worms, but I definitely I definitely felt like I came through at the end and was like, all right. I know enough to be dangerous and to figure things out and to like learn on my own. But I definitely did not walk out of there a master of Python, that is for sure.
No, I always tell people with analytics or these classes, some of them, there's some of them in graduate school and business, and has kind of a ringer for those classes because I've been working in it for a while. But I said, even if you never use it again, now you know like what you can do with it. At least you have like the domain knowledge, and that'll help you like connect with other people that we're talking about, or have some idea how to utilize data for your own purposes. If you never use Python again, like, which you may or may not, like, at least you know what it could be used for. And if somebody in your business is, you have a data scientist in your business, and you could connect on that knowledge, have a good idea how to utilize them.
Yeah, I was talking to my boss about how we're kind of coming to an end and what I hope to, take and use at work. And I was like, Tableau, I feel kind of comfortable with, but we don't have like a data scientist or any person that's skilled like that in my office. And so I'm like, I definitely will need to like connect with the community to make sure, what I'm doing is, I'm communicating it right. I'm considering the right things. It's ethical. That was a big thing we learned in the Tableau piece. But knowing that I have people to kind of review with, or at least touch base with, as I'm the only person at my office kind of messing with this stuff. So
no, now everybody, you'll be the go-to person in the office, right?
I know. I had to tell her, I'm like, I can figure it out. It's not gonna, it'll take me a minute. I'm not some super speed. I'm still getting comfortable with these programs, but I can figure it out.
No, if you like Tableau the most out of these classes, and it's the most interesting, maybe one thing that will help you now is that you have SQL to be able to bring together some data from the database.
Yeah,
and like
absolutely.
oftentimes I still do that. I still bring the data together, and then I put it in a view or some code, and then I import it into Tableau, create the
I definitely
visuals. So now
see
you
how.
have like the power to be able to bring some of it together yourself, hopefully,
Absolutely.
and kind of have a understanding and a appreciation for these databases. Maybe not an appreciation, maybe that's a stretch, but
Well, no,
understanding.
definitely appreciation, but I appreciate it because it's a skill for sure. But yeah, I definitely see how SQL and Tableau work very, very, not that Python doesn't, but I could see, working and having both programs up and going back and forth and stuff.
Yeah.
So
maybe as much as anything, how they all connect too. So like with the MBA, in the MBA program, a lot of these people will go on to be managers, and they won't be as hands-on as much, but they'll kind of remember the time where they did things, and maybe they have a use for the skill, or be able to hire it, or know their resources on their team or their organization. Yeah, I don't even know how many times I've been in business, even at bigger places, where people just didn't really not have any idea what I could do or the capability or anything like that. So hopefully part of this education is all of that too. I think you have to educate people on it.
Hey, Ronnie, are you taking the next 3 set of classes?
I would like to, but it really depends on Nate and what his vision for it in education is, and allowing me to participate. Because I'm kind of I'm not a business entity per se, and so I think that's the plan. But I think, Jeremy, this was the last class that we were doing before COVID hit, wasn't it? So I don't think or maybe we got started into the 4th class, because who's the next instructor we'd go with, Jeremy?
Gordon would be, yeah.
I think maybe got started with him.
Yeah.
and then everything got canceled or put on hold. So that would be my plan, is to continue on, but I don't know how many others Nate's got lined up, for if it would just be us two or if there's others,
I think you might have them planned. I could take a peek real quick. See if I could get you an answer to them. So I guess the biggest thing is if they have enough people to go through it or not. If you have two of you. Let's see. Let me try to find this real quick. And more as you're working on, you want to catch up here on the class project.
Yeah, I just reached a stopping point at milestone 3. It's saying that my drop and create commands are denied.
Okay, hold on one second. I'm trying to look up some information here on the next class. Hold on one second. Let's see.
Because aren't the next 3 classes? What's your understanding of them, Michael? Just Python at second level or something, and then more Tableau as well?
I don't think it's Tableau. I think it's about creating models and analyzing models.
Okay.
And that's really what I'm after. And so I really am wanting those classes to still take place.
Yeah, so when I teach the advanced class, it's advanced Python, but it's with doing data analytics with it. So you do natural language processing. So it's like feeding these algorithms text and returning themes about the text or grouping text accordingly. So it's actually kind of interesting. But it's really a combination of the predictive analytics and machine learning, and then using Python along with it. And that's what Gordon will teach. He does the model building itself and the mathematics around it and stuff like that. So it's really kind of a different set of classes. It's more of the first 3 are the data analyst, BI, foundation classes for using data, and then the rest of it's the rock star predictive analytics stuff.
But the machine learning and the AI, that's what our data pathway at South is supposed to, go into. And so obviously the pathway is not totally built because we have to have trained teachers, but maybe when I retire as an administrator, I'll go back as a teacher.
Oh, you guys are doing a computer and AI lab at South?
That's the down the road. But we just have the freshman academy now, and then, the basic foundational ones at the junior and senior level. And if not taught, at South, contracted with people like yourself, Jeremy, to teach remotely, the students or whatever. So, we're just brainstorming and putting it together. But again, to get the next generation of technical folks, in the Omaha area, and start at the high school level recruiting them.
Yeah. No, I think that you could do AI and machine learning in a more simplified way that you wouldn't for high schoolers, and not get into the mathematics or anything like that, or the nuts and bolts of it. Just even something like voice recognition and training, something like Siri or Google or Cortana to be able to do certain tasks. That's machine learning in itself.
Well, and then
Able to identify photos, or there's a cool one. I saw a demo of this at Heartland Developer Conference like 2 years ago before COVID. That this guy took the pictures of all the sides of the Rubik's Cube, and the algorithm solved the Rubik's Cube for him.
yeah, wow.
It's pretty cool, but I think that's something that would, like, if you could kind of show them how it works and how to do it, then maybe.
Well, back in my day when I solved the Rubik's
Go to
Cube,
college for it.
I got the the codes offline and taught myself how to solve it. My son could solve it like behind his back.
So a real life situation for my son and I is he was tearing down something. I think it was our wood splitter, and there was a piece that he needed to get a replacement for, or a different piece, something like that. And we didn't know what the name of it was, so we drew a picture, and then we used image processing to identify it, and then give us the name. So then we knew what kind of tool to buy to take it on and off. And it was actually called the snap ring. And it was crazy to see it, where we draw it out by hand and it wasn't perfect. And then we ran it into the image processing, and then boom, it popped back and said like these, and it showed us other examples of things, and then gave us the name. I was like, that is amazing.
It's pretty cool.
Well, and then to have it hooked up to the 3D printer and just make the part for you. I mean,
oh yeah, that'd be awesome too.
That's, and that's the robotics, side of it. And that's what, our kids are, doing 3D printing as well. But yeah, and I'm back to the machine shop. When you say the wood splitter, that's funny. That's what my dad created, a wood splitter on the tongue of a trailer, and a hydraulic, and he designed it and almost patented it. I'd love to see your wood splitter to see how close it is to my dad's original. The wood splitter on the tongue of a trailer, and so you split on the tongue and use the hydraulics to dump the load on the trailer, and
it's pretty cool to see how many different ways those things have been put together.
So, Ronnie, I see that Nate doesn't have a class for basic model building scheduled until January. So I don't know if he needs to gather some additional interest or not. So if you're interested, I talked to him about it.
And that's, Michael, what you're interested in continuing on as well, correct?
Oh, absolutely. Yeah, that's the heart of what I was actually after the whole time is those classes.
Emily teaches it instead of Gordon, and she'll teach you basic model building. I think she works with Kiewit. I've met her once. But she seems to be bright, and she does predictive analytics.
Cool. Yeah, for me, I'm not surprised that it's going to be in January, because I remember Nate having that conversation with me before things got started, that after this, we would basically break for holidays and then go back at it.
Yeah, I think he has some plans for additional classes, Data Science Academy classes in January. Get back up. Hey, Maura, did you want to share a screen? I could give you control, or either that, or
so why
do
I have to? Yeah, I'm messing with this from
Milestone 3.
Yeah.
Okay.
And so I'm doing where I'm trying to create the table console game sales.
Console game sales, okay.
Okay, let me see if I can.
Or was this where, say, not from the SQL file, but you were importing some of this data?
Yeah, and so I don't know. I don't know if I'm just kind of confused on like first steps here or what. I guess.
That's probably from lecture 3, right? So I'm going to bring.
I think it's lecture 4 is what the class. It's milestone 3. It says class 4.
Okay. Let me bring this up. From joining and merging data.
Yeah.
Take a second here to bring up the PowerPoint. Okay, it's still opening. There we go. Just kind of have to be patient. All right. So class for milestone 4 or milestone 3?
Milestone 3.
Okay. So we had these questions. Let's see. Was it part of it importing this data, or is it still answering these questions, Maura?
It's answering those. I feel like answering those questions are kind of at the end. I'm kind of struggling on where to get started to go about this, I guess, a little bit, and I don't know if I'm finding the right data
no
to
problem.
import. Yeah, if we could just kind of walk through it step by step, and I'll follow
So to
along.
better understand the marketplace for video games and consoles, the CEO would like to know the following questions. I guess I didn't really point you to the table to answer these questions.
And then there's like
You might
you
have
can
to
go
import
into
them.
class project and milestone 3, and that the stuff is in there, but I'm having trouble running that, and I
Okay.
don't. Yeah, I just.
Guys, I got to step away just for a couple minutes, and if you were trying to talk to me, I just letting you know I got to run downstairs and help my husband log into something, and I'll be right back up.
Yeah, no
Okay.
problem.
Thanks.
Milestone 4.
Milestone 3, class 4.
So my milestone 4, the research union and join, matches up with lecture 4. Is it that way? Or on
Like
different-
I have like the class project. I'm on.
This is the one
storing-
you have open. This
I
one.
have the class project lecture. In lectures.
Class project and lectures.
Yeah. That's what I've kind of been referring back to.
Oh, that folder. Yeah, that should. Oh wait. You'll want to go. Actually, you'll want to match these up with our current PowerPoints.
Okay, so the class project.
I changed that up a little bit. Yeah.
Okay, so the class project PowerPoint is not up to date.
Yeah, that was like an old one. I should move that into archive. I put each one of these at the end of the newest version of the PowerPoints.
Okay. Maybe that's where I was coming across problems. But I still pulled up the lectures, and class 4 is still milestone 3. Joining and merging data.
Kind of a mismatch here. Class 4 is milestone 3. Let's make sure we all have the same code here. So this is lecture 3, so I'm just doing this out loud. This is where we're loading these tables.
And you already did that for us, correct?
Yeah.
Yeah, so that's, yeah, because that stuff's already all in there.
And that matches my, 1 second. Oh, I'm just making sure all of mine matches up in it. That it's not something different than what you have in Google Drive, which would cause confusion.
Sorry.
Give me 1 second.
And then I don't know if anyone else. Oh, my dog. Sorry, guys.
Yeah,
I don't know if anyone else. When I'm opening the Google Slides, it like a window pops up, and it's like you're not going to have access to this for much longer, and is recommending me making copies of them. And I don't know if anyone.
Oh,
else
it does? I haven't
Yeah.
heard of that. Could give one a try to open up one up and let me know. I'll try to fix that now.
Yeah, like when I went to open. Well, now I don't know where it went. Okay, let me see. Well, now I can't find class 30. Now it's not even in the lectures folder. But it was doing it on 7.2.
All right, let's do this.
Yeah, I don't see lecture 3 anymore either. No, I do. It's actually, it's the left parent, 3 right parent, extracting and storing data. It's like 3rd from the bottom.
Yeah,
But
I'm
it
not
shows.
seeing it. It's weird. So oh, my dog. It was weird. It was like every other time I opened up a PowerPoint, it wasn't. I don't know. That's not what I meant.
Yeah.
Oh, okay, there it is. Now let's.
All right, I'm going to open this up. I updated this just at 3 o'clock today. I think is the most recent version of all of these. More, do you see these 1 through 8 in the extras?
In lectures.
Yeah.
Yeah, well,
Do
I
you
see.
see something different?
Yeah, I see it. I just refreshed my page, and now I'm seeing it. But gosh.
Actually, I'm going to click on these instead of these PowerPoints. Are you downloading these or just opening them up?
I'm opening them up, but now it's like every time I click on one, it's opening. I don't know what in the world is going on with my computer. I don't know if it's me or my Wi-Fi, but every time I click on one, okay, let's see. This will
Your
work.
sound and video seems good.
Yeah, every time I
No.
go to open lecture 3, it like straight clicks for lecture 1 and opens only lecture 1. I'm having so
It's
many
weird.
issues.
So this is the right one that I want for 3. That matches my PowerPoints.
I do not know why that is going on. That is just the weirdest thing. What the world?
No, these seem to be in sync with my PowerPoint slides because I added the select and where and from subqueries.
Okay, now it won't even let me open up the class 30 slides. Maybe I just need to restart my computer or something.
Anyone else having trouble?
I'll try to open a few.
Yeah, I'm gonna, and we're talking in the downloads on the Google Drive. Is that what you're talking about?
Yeah, I'm in the lectures folder on the Google Drive, and I'm just trying to open up the PowerPoints, and it's okay. Maybe it went. I just kept refreshing my computer, and now it finally.
These seem okay. I think these are all up to date.
Okay. So for milestone 3.
Oh.
Maybe this one more. Data storage and manipulation, or still the wait. So okay, lecture 3 is milestone. I have them mislabeled, which is kind of be confusing. My SQL Workbench froze.
And then am I supposed to use like the class project folder and use those milestone
Yep.
documents to help get me to the next milestone, essentially, I guess?
Yep. So the idea here is that
Yeah, so
I help you put it together and make
Yeah.
sure you can walk through it, and it's like a real life project. I don't make you classes a little short to do it all on your own.
But we already did, or the milestone 2, you already uploaded those tables.
Yes. Let me.
So that's done. I have dates, game rank games.
Yeah. So milestone 2 was like lecture 2 asking these different questions.
Mm-hmm.
Okay. So examples, lectures. Some milestone. I have 2 copies of that one. I'll get rid of one of them.
Yeah, and I've done milestone 3. It's milestone 2. Milestone 3 is where I'm not really sure how to get started.
Build the tables. Okay, that goes with lecture 3. See, so it's create a table console game rank with the appropriate data. So what I think I
so
do
what is
here
milestone?
instead,
Wait, what is milestone 3? What lecture?
I have that going with lecture 3. And these data storage and manipulation, like creating this table. And then creating a SQL script that manually inserts the values. So that's what I'm doing right here in milestone 3.
And are there 2 different PowerPoints then?
Yeah, every time I open class 3 PowerPoint, it says it's milestone 2.
And there's lectures inside the class projects folder. And isn't there lectures just at the main level? Are those the same exact lectures?
Mm. So these were, I originally had this separate. So I'm going to put that one in past projects to avoid confusion. I wouldn't take a look at the lectures.
Don't look at the lectures. Refer to the lectures that are in just the data management or manipulation management level.
Yeah, because I have them all in the PowerPoints, the main PowerPoints now.
So before, Jeremy, I'm on the same PowerPoint slide as you right now. Yeah. And this is lecture, or this is class 3.
Yeah, this one's class 3.
Yeah, and so this is milestone 2, because it says
3.
class 3 milestone 2.
How do you see what his PowerPoint is?
I actually line these up with the lectures so they don't, it's not these numbers here, it's a class number. So I said like milestone 3. I think that might be part of the confusion too. So I should probably really number these like milestone 1, 2, or 3. But I named it milestone 3 and it matches class 3, and milestone 4 matches class 4.
Okay, because I'm reading it as class 2 or class 3 because what's in parentheses, and that's milestone 2.
Yeah, I should probably change these to. I didn't think about those. Make these the milestones here, that numbered list, and instead of saying milestone 3 with the classes.
Yeah, maybe that's what was confusing.
Or I could do, instead of milestone, just say like class 3 for the project.
So is the screen on class 3, slide 15, the green, I think you're on it. Yeah, what you just highlighted.
Yeah.
What milestone is that?
Milestone 3.
Okay. So go, okay, I'm following.
Mara, how are you
And my
seeing
bad
his
with the
screen?
confusion number.
I'm on the. I've opened the same. I have the slide deck
Am I
open
still
through,
am I not sharing it?
through Google Drive, and so I can see him on it on working on. Google
Okay,
Drive.
and I just opened that, so I was just
Jeremy.
trying to pop it. I'm like,
Yeah.
To answer your question, no, it's just the four of us. Now you're starting to share.
there you go.
Sorry to interrupt you, Ronnie.
Nope, I was just like, how's
Sorry,
Mara
I
seeing
think
it?
that
I
Laura and
can't see
I
it.
we were following along together, and I didn't realize I was
Got it.
not sharing.
And so I went to the class project and opened the milestone 3 like script or whatever.
Mm-hmm.
And I'm struggling running that. And so I don't know if I maybe missed a step.
I'm so glad you got to it, Mara. So I'm just struggling along with you. So I haven't had time to.
God,
I'm gonna
God,
get to where
Jeremy-
you're at.
I think Jeremy just bailed on us.
Well, you
His-
know, we
his
didn't
computer-
challenge him until tonight. with questions, so.
yeah, my questions are gonna start flowing, man. That's all I got.
Well, and as I create my own database and schema, I want to replicate it as we're doing it on these milestones, but build my own
Yeah,
on
yeah,
another computer next to it. So that's why I want to I got to know what's happening here.
yeah, yeah. I started getting going, and I'm like, all right, here come the questions.
Mhm.
So glad we're all in it together.
Now, correct me if I'm wrong, but he still has the
just-
4 of us. You don't have our screen.
Yeah, sorry about that.
That's all
My
right.
computer was going slow because it froze my SQL workbench, and I just closed the wrong one. I killed the wrong task and kicked me into this thing.
No worries.
So no, where were we? We're with making sure we're on the same page with the milestones.
Yeah. So then when I go to the class project folder in Google Drive and click milestone 3, I've tried to run that first set, and I'm having issues with that.
Yeah. So
And I don't know if I missed a step or yeah, I guess I'm struggling to figure out kind of how.
let me try to restart my SQL workbench here. I think one of the things, Maura, if you were running that under the class projects schema, you'll want to change that to that first part to mramsey. And that might be
okay. And
part
I
of
think I
it.
tried that, and so there's 2. I guess I didn't do it on both. So let's see.
Give that a try first. So I created them all under class project, but with the permissions that you have, you'll want to create that their own schema.
Oh, okay. I just needed it. Okay, so I put my name in like the first one, but I didn't do it in both. And so it worked. I created a table.
Yeah. And then,
Okay.
inside your own, if you do that insert, now if you do the mramsey and that pre-order sales, you should be able to insert data into it.
So whenever it says,
Good.
okay, because when I was doing the milestones previously, I had to put class project in front of things, and now going forward, I need to put
Yeah.
emergency. Okay.
Yeah. All right, I didn't make that clear.
No, it's okay. I was just like working through the beginning, and I put that together at the beginning, and then when it did say to start building it in your own schema, and so, I mean, that was a pretty quick fix for me. I just, it was taking me a minute.
Instead of milestones, I'll call these project lectures or something. That or just number them the same way they are in the slides.
Okay, that got me over my my hump. That's for sure.
Yeah, no problem. Sorry for the confusion there.
No, it's okay. I was like, am I missing a step? And then I'm like trying to kind of work through, and then I don't know. I was like, I knew we had already done something, and
yeah, even in these exercises, I start to use my schema, but no, I kind of kept the class project in there to show you how I build them in the class project, but you really need to need to change them over. So you can do that in yours. And that way, too, you can build it and wreck it or mess around with it and no harm done either. That's kind of the idea, is that then you can experiment with it or the code.
But slide 6 in the class project, those classes line up with the milestones where it says class 2, we're querying data for data understanding relative. That's class 2.
Yeah.
Then in class 3 or lecture 3, that's milestone 3 as well. Import data into MySQL database.
Yeah.
And
Yeah.
then for
Yeah, these maps of classes. Yeah.
Okay.
It's just that ordered list goes from 1 to 7, and the classes go from.
So I just got another error code that's telling me I should disable safe mode. Is that
Yes?
Should I do that?
Yeah. So there's in an example earlier on. Or in your. Okay. Hold on one second. Let me just find it. I think in this examples PowerPoint SQL, if you search here.
How do you even disable?
Here, actually, I know I have this in here somewhere. There's a command that you need to run.
So it's saying to disable it, toggle the option in preferences. That's what I was told to do.
Yeah, you might be able to do that.
But I can't find preferences.
Okay, hold on. Let me see. I'm looking for this. Set SQL safe updates. Is that, what was it, error, Mora?
Oh, 1175 was the error. And it says you are using safe update mode and you tried to update a table without a where that uses a key column. To disable safe mode, toggle the option in preferences, then go to SQL editor and reconnect.
Try to run this piece of code.
Okay. Are you putting it in the chat?
Yeah.
Okay.
Hey guys, I gotta go. I got a guest that's helping us do global entry applications for our trip to Ireland. But I did get all my stuff installed on the other workstation tonight, Jeremy. So I'm gonna try to do the project stuff, but possibly with my own tables and data, real world wise, just copying what the instructions are.
Yeah, go for it.
So we're gonna have to ask you about Ireland. I just don't know when.
Oh, I'm going for the Husker game next August.
Oh wow, cool.
The Husker game in Ireland?
Yeah, it was supposed to be this August, but because of COVID, so I'm part Irish, and we had taken my husband's Mexican, and so we had taken the kids to a wedding in Mexico of a family friend and got to see his, roots. He's born in the United States, so was his parents, but you know what I mean?
Yeah.
And so when we got back from that trip, his Huskers, because I'm a Hawkeye, are playing in Ireland. I said, okay, now it's time to go, check out my roots. So
let's do it.
Why are they playing in Ireland?
Every year there's a bowl there just in like Notre Dame, and the team played. So they invite teams that have a strong fan base that travel just kind of as a cultural experience, but that they know they will get tourism, and we were all signed up to go and paid for to go this August, but it got delayed because of COVID, and they were actually able to arrange for it next fall. So,
and it's an excuse to travel, right?
Exactly. But we all want to have our travel, then we're doing it together. And so we have to do this global entry application so that we don't have to, wait in customs and all of that. So
Well, that's going to be so fun. Ireland's a cool place.
you've been there?
Yeah, I went a couple years ago. Well, my family thought we were Irish for a really long time, so I also thought I was going to see my nephew
Okay.
Turns out I'm Russian and super Swedish, so not Irish at
There
all.
you Okay.
Which I probably should have guessed because I definitely look more Swedish.
Uh-huh.
But yeah, I ran around there. I went and stayed with a friend who was studying at Limerick University, and then I had an old family friend that moved to Dublin a long time ago, so ran into him and a couple other places in Europe. But it's very beautiful. If you can go to the Cliffs of Moher on a clear day. I went on a really cloudy day and I was walking along like the edges. I'm like, wow, this is crazy. And then I saw pictures of what it looked like without the clouds. And I was like, oh my gosh.
Yeah. Kind of like going to Mount Rainier or whatever.
I'm like, I cannot believe I was doing that.
Uh-huh.
But
no, we're doing an 8-day trip. So we'll see the Huskers play, but my goal is to see all the other sites.
Yeah, you'll definitely be able to knock out a lot in that time. So
cool. Well, I will fill you in more next week, but I want to get down there and work with them. So I will let you guys keep working if you're going to work, but I got to leave. Okay.
Wonderful.
Okay.
Have a good one.
Take care.
All right. Thanks.
See you.
See you Monday.
For the final
Bye.
week. Bye.
You bet. Bye.
All right. And then Jeremy, all right. I got past my humps, like I said. So I'm good to, I think, keep working on it on my own. I'm sure.
Did that command work? That set
Yep.
SQL safe updates?
Yep.
Okay.
Yeah, that did. It got me right
We
where I
ran
needed
into
to
that
be.
in a previous class. I'll drop that in this PowerPoint SQL. I was just pulling all of these out of the slides and forgot to add that one back in there when you're updating. When you're updating tables.
Yeah. Well,
So
I'll definitely.
A good point to keep moving forward on it.
Yeah. I definitely feel in a better spot with it. I'm sure I'll have plenty of issues come next class that I need to work through. But yeah, it's coming together and I'm answering my questions. So yeah.
Cool. Yeah, the next classes aren't Q intense as far as the project goes. So you have the opportunity to catch up and finish it. And the end goal is that we load it into Power BI and visualize it.
Okay.
Answer some questions.
Yeah. So I'll keep going. Again, I won't be being class on Monday, but I'll try to watch the recording before.
Yeah, no problem.
But that's that. So I'm gonna check out for the evening.
Great. If you have any questions, feel free to email and enjoy the trip.
Wonderful. Thanks.
This time of the year is hard going west though, because it could snow, but it looks like the weather's nice.
Yeah, and we're only going for a day, which kind of dumb, but that's fine. I get told what to do and I do it. So that's where I'm at in my life.
And there we go.
Yeah, so we're going to Scottsbluff for a day. We're going to Scottsbluff for a day. I don't have much of an argument.
So are you flying like a small plane or somebody flying you there, like a personal or?
Yeah, so I don't. One of our chairmen is lending us his plane for the day. Yeah. I don't know if it's like one of those little tin can planes, and I really hope not because my mom's side of the family flew those growing up, and those just I don't do well on those. And then I got to take my anxiety meds. And then if I take my anxiety meds, I'm not going to be very alert during a meeting. But if it's like the jet, I can be a little more comfortable on those. But those little tin can things, there's just been too many freak accidents in my family. I just think I carry bad luck. So hopefully I'll make it back for class, the final class next week.
We're rooting for you.
Cross my fingers for you.
Everyone send good juju my way because I don't handle those well. But like I said, I just do what I'm told. So alrighty.
Yeah, good luck. I'm not sure what type of flight that'll be, but maybe it's just somebody flying you there, like a
Yeah.
passenger, whole
Yeah.
passenger plane.
That's what I'm hoping for, because I can handle those much better than those little tiny ones.
Yeah.
And you'll have a fun story to tell us.
Yeah, hopefully just smooth sailing, but
It'll be awesome.
I'll report back next week. Just wish me the best.
All right.
All right, see you guys.
Good luck.
See you
See you
later.
next week.
Bye.
Bye. All right, Michael.
Hey, I'm still sitting. It looks like I got my head on the couch.
Gotcha. So, were you actually taking piano lessons?
No. When where I grew up, we had a piano, but it was a stand-up. But I don't think I ever took piano lessons. We got piano lessons for both boys. And this is definitely not our house. We've got a fireplace, but not like that. And we don't have a baby grand. So this is just a stock photo.
Oh, God.
Yeah.
I was all confused. I was wondering. I was like,
No.
oh, Michael had piano lessons. Is that someone else's house? I'm dumb. All right.
No. This is just stock photo. I need to get my basement finished. So there's no part of it that's presentable right now.
I gotcha. I should think about putting up a background on mine too. I guess the cabinets aren't bad.
No, yours
Actually,
looks
I have
good.
a little like some records, some vinyls back here, and you don't see the bottle of whiskey here, but I have one of those.
No, everything
here.
Everything that you've got is looking good, and the thing is that it's actually, I think, having a natural background just all around works out better. So
Yeah, we put the work in on this one a few years ago. Put some cabinets in behind, and it's kind of working out. Finally, after we've been living here since like 2008, it's finally coming around. It's almost home. But there's always something new. There's always when you think you're done.
yeah. My surprise is the fence. So we got a dog, and so it's like, oh, need to do a fence now. And I tell you what, even though we've got a power auger for the digger, it was a 12-inch hole, and trying to keep that thing under control while we were digging was just workout.
Yeah, it's hard work.
Yeah.
Yeah, we did that. I got it done in a day. We did like 15 of them, but I was worn out. We dug them 18 inches each.
Oh, okay. Ours are 3 feet down. And,
Yours are 3 feet?
Yeah, because we need to go half the length of the.
Yeah,
we need to go half the length of the post, and we're supposed to put a foot of rock underneath. So all the holes are 3 feet.
Maybe we did ours 2 feet. It wasn't 18 inches. But we have 6 foot wood fence.
There you go.
But, all right, Michael. I didn't get have to finish up something for James here that I promised.
Hey, no worries. I've got the same thing going, so no worries at all.
A lot going on.
Yeah, and then we'll catch up tomorrow.
All right, deal. See you tomorrow.
Yeah, have a good one.
Yep. Bye.
Bye.
All right, let's finish this broadcast. thank you for joining us tonight for this Omaha Data Science Academy class, or Data Manipulation and Management Class 6, which focused on database design, structuring, and modeling data. Join us next time when we cover storing and managing data, particularly within the context of an enterprise. So how they store data for business intelligence and analytics, manage the data, store and extract, and do data governance and stewardship. So until then, I'm Jeremy Bergman. I will see you next time. Bye.